this question claims that if the function is continuous everywhere and f of a and f of b is greater than 0, then there's no root, so no place where we have an x-intercept in the interval a to b. All right, so let's think about this. So one picture that we could draw is that we could have our f of a and f of b, they have to be greater than 0. So who knows if they're equal or what's going on, but they're greater than 0, so they're above the x-axis. And it has to be continuous. So I have to draw this little squiggle between f of a and f of b without lifting my pencil. So I could draw a squiggle that looks like this. Now if I draw a squiggle that looks like that, there's not going to be a root in that interval. But I mean, think about it. You could also, there's nothing stopping you from, okay, here's f of a, here's f of b, and I could draw a squiggle that does have a root, because that's what we're trying to prove. We're trying to prove that, or show a counterexample potentially for this statement. So is there a way that we could go from here to here without lifting our pencil and have a root for the equation? Or for the function. So I could do that, right? Because I could start at f of a, I could squiggle down, and if I got to go back to f of b, I could potentially cross the x-axis and have a root. So this one doesn't really show anything, but we could draw this picture as a continuous function where f of a and f of b are greater than 0, but there is a root. So this would be classified as our counterexample to show that that statement is a false statement.